has more than 50,000 buildings that consume 90% of its total electricity, with air conditioning systems consuming around 30%. Also, refrigerants in air conditioning systems are a major cause of ozone layer depletion, contributing to global warming.
Global warming is a common problem faced by mankind. Earth is continuously heating and its temperature is rising due to the increasing amount of greenhouse gases in the atmosphere, primarily carbon dioxide from burning fossil fuels. This increase in temperature is causing significant changes in the environment, including melting glaciers, rising sea levels, and more frequent and intense natural disasters. To reduce carbon emissions and energy consumption, humans are seeking together for a greener, environmental-friendly, and innovative solutions for wide application. GEMER International proudly introduces eco-friendly and efficient products to help fight against global warming, heavy air con use, health problems, and high electric consumption. Radicool, power-free cooling technology, published in the world's top scientific journal Science, attracted wide attention of international academic and business circles and the general public. Developed by team of Xiaobo Yin and Rongue Yang from the University of Colorado Boulder, USA in 2017, the technology was named as the Top 10 Breakthroughs of the Year in Physics World and rated as Top 10 Most Popular News in the Economist Group. Radicool is a breakthrough cooling technology that continuously and effectively dissipates the heat away without any use of electricity even under direct sunshine. Radicool works like the natural cooling process of the Earth. When sunlight strikes, the heat inside the structure it covers is transmitted out to the cold outer space, thereby achieving radiative cooling. With its cool and excellent features, Radicool can achieve 30 to 34 degrees Celsius improved surface temperature and 10 to 15 degrees Celsius improved room temperature. As an innovative cooling technology which is energy-free and pollution-free, it appears in various product forms such as Radicool transparent film for glass door, window, and skylight glass, Radicool reflective film for roof and GI sheets, Radicool paints and coatings for walls and roofs, Radicool fabric to produce curtains, tents, and car covers. It can be used in huge buildings, commercial establishments such as airport and shopping malls, residential houses, logistics, and transportation.
Actual Radicool projects. Changi Airport, Singapore. Without Radicool, 45.3 degrees Celsius. With Radicool, 31.7 degrees Celsius. Great results made the airport management decide to fully install Radicool on all the terminal glass window panels. Hangzhou Xiaoshan Airport, surface temperature. Before, 62.4 degrees Celsius. After, 33.6 degrees Celsius. 14.7 degrees Celsius air difference inside the PLB and near the glass. 5.7 degrees Celsius air temperature difference in the middle region of the PLB. With Radicool applied on only one loading bridge, the airport achieved 55,000 kilowatt-hour annual savings, which translates to 43.7% annual energy savings. Foxconn, iPhone manufacturer, built two model house unit for testing. One is installed with Radicool and the other one is just a base unit. Results showed that the house unit with Radicool can achieve room temperature difference of 16 degrees Celsius. To test it even more, they install an aircon unit in each of the two house models, which was running 24 hours for 30 days, and came up with the following result: 60% daily electricity saving rate during sunny days and 30 to 35% daily electricity saving rate during rainy and cloudy days. Ken Electricity Room, Japan. Normal surface temperature, 53.6 degrees Celsius with Radicool, 22 degrees Celsius. Achieve 31.6 degrees Celsius surface temperature difference. Local projects. Applied transparent film on glass window and doors for UV protection and much controlled temperature. Dynalupian, Bataan. Outside temperature, 35.6 degrees Celsius. Inside temperature, 27.3 degrees Celsius. Macquarie Group of Companies. Whack Whack Apartment. 1 Surendra.
Panels. In radiant panel type cooling, copper tubes may be used for circulating chilled water. Piping. Loops of cross-linked polyethylene pipes are embedded in walls, floors, ceilings, and chilled water is passed through them. Control system. Along with the switching controls, these controls may also be used to regulate conditions using inputs from various sensors. Chiller. A chiller is used to cool the fluid medium to required temperatures. Other components. Other components like manifolds, valves, pumps, etc. complete the layout. Chilled water from the chiller goes to the manifolds and is distributed through the grid of pipes installed in the room. The chilled water in the pipes then absorbs heat from the ceiling or the floor, making it cooler than the objects and the occupants in the room. The resultant temperature difference ensures that heat from the bodies is now radiated towards the cooler building components, leading to a sensation of thermal comfort. Radiant floor cooling. As the name suggests, pipes embedded under the floor cool the space above in this layout. Radiant ceiling cooling. Installed directly below a structural ceiling, panels with embedded pipes or pipes attached to the ceiling and covered with plaster. Radiant wall cooling. Small diameter pipes are attached to walls, then plastered over, or panels with embedded pipes are mounted on the walls to achieve radiant wall cooling. Pipes may be run from the floor as a same circuit, or a distinct circuit can be installed. Latent heat load management using a dedicated outdoor air system. Comfort is as much about humidity as it is about heat. While radiant panels take care of the heat in the air, a dedicated outdoor air system is essential to handle humidity along with dehumidification. The dedicated outdoor air system accomplishes ventilation and filtration. The air quantity requirement in this system is much lesser when compared to a typical air-based cooling system. Together with a dedicated outdoor air system, radiant cooling can completely address the thermal comfort requirements in any climatic zone. Using heat exchangers in the form of chilled water carrying pipes embedded in floors or walls or ceilings or in panels ensures the availability of a much larger area for heat exchange compared to a regular heat exchanger, which is impeded by space constraints. Sufficient cooling can be achieved with higher chiller operating temperatures, which in turn results in a higher coefficient of performance for the chiller and consequently lesser energy consumption. A room with a regular air-based cooling system has a higher mean radiant temperature and therefore needs a low room air temperature to make the occupants feel comfortable. A radiant cooled room, however, has a lower mean radiant temperature and can provide the same cooling effect at a relatively higher room air temperature. In radiant cooling systems, which have a dedicated outdoor air system as well, the air requirement is considerably lesser than a regular air conditioner, which is also reflected in the reduced power consumption of the overall system.
Buildings have always lent skylines to numerous cities across the globe, and increasingly they are becoming icons of creative infrastructure. The fact that these very buildings emit 19% of energy-related greenhouse gas (GHG) emissions and are responsible for 32% of global energy consumption suddenly put things in a different perspective. It is estimated that India will have more than 100 billion square feet of constructed space by 2030. Interestingly, 80% of these buildings are yet to be built. This puts India in a remarkable position to pursue and demonstrate a path of green construction and operation of buildings. Urja Energy Engineering Services Private Limited, a Hyderabad-based company focused on providing energy-efficient solutions for commercial and industrial establishments, have recognized this opportunity. They have developed an innovative technology, radiant cooling solution, to significantly reduce the cooling energy consumption and its associated carbon footprint, which are responsible for 55% of energy consumption in this sector. Intriguingly, distribution of cooling, which is a significant contributor to energy consumption in commercial buildings, remains a neglected area. Urja Energy's radiant cooling solution addresses exactly this overlooked aspect, focusing on increasing efficiencies in cooling distribution. This solution involves turning surfaces in the room, like the floor or ceiling, into a heat sink that absorbs the sensible heat in the room by embedding pipes in them, instead of blowing the air over a heat exchanger as is done in a conventional air handling unit. Being at a lower temperature than the heat sources in space, these embedded pipes absorb the heat radiated from surfaces like walls, glazing, furniture, etc. These pipes have chilled water circulating in them, and the heat is finally transmitted to the water flowing in these pipes. The heat thus taken away is rejected to the ambient using a chiller. In addition to floor cooling, Urja also offers radiant cooling solutions for walls and ceilings by placing the heat exchange panels in the room itself. Conventional centralized HVAC system using chillers and AHUs requires chilled water supply at 7 degrees Celsius, as compared to Urja's radiant cooling system that can operate at chilled water supply between 16 to 20 degrees Celsius, leading to significant savings in the power consumed by the compressor, as the compressor has to work more to produce chilled water at 7 degrees Celsius. Furthermore, the solution does not require a high-powered motor to transport large volume of air through the ducts, offering a reduction of 30% in energy consumption. Thus, Urja offers a financially viable solution that can pay back the cost in less than 3 years, depending on the nature of the project.
Savings towards the energy is phenomenal. Example, if you compare with a conventional system, this technology, it's giving somewhere around 20 to 30% of energy savings in terms of power consumption.
In addition to lower energy consumption, the system comes with many other benefits.
The indoor air quality has improved now. We see people are very energetic. People were very comfortable because uniformity, the productivity also improved.
With lower energy consumption, uniform comfort, better indoor air quality and reduced noise, Radiant Cooling Solution thus provides a sustainable way to cool our ever-increasing energy-guzzling buildings. If this system is implemented globally, it can mitigate 30 million tons of GHG emissions by 2025.